So hello guys, what's up? We are back again with another question from our DSA challenge series. So let's get started. So guys, today our question is flatten binary tree to linked list. Yes, this is our question. Okay, so let's see how we can approach it. So in this, we are going to make a tree getting into a linked list. Now, how we can do that? For example, and the linked list should be in same order as the pre-order traversal. So yeah, so it should be similar to a pre-order traversal when traversed from a head node to the tail node. Okay, so what approach we can see? So we know that we want. Okay, so in pre-order traversal, what we do, we print the node, we go to the left, and then we print that and print the left subtree, and then we go to the right and print the right subtree. So we only have to change the node. One way is to print the pre-order traversal, then take out the values and then make the nodes and do it that way. But that is not the optimized way. What we can do is, and what we should do is to think a solution in which we are changing the pointers. Now, how we can do that? Let's see. So if you see this subtree, 2, 3, 4, this is into the left of this. So after 1, this subtree will be called 2, 3, 4. So what we can do is, and then 5, 6 will be called. Now we want to eliminate the right pointer. We need only the left pointer of 1. In a sense, sorry, we want to eliminate the left pointer. We need only the right pointer. So what we can do is, we can cut off this pointer and we can make 1 attached to one's right pointer attached to 2. Now what will happen to this 5, 6 wala subtree? This subtree will go to the rightmost value of this subtree, as this will come after this. So this will look something like this. 1, then 1 is connected to 2, 3, 4, and then 5 and 6 will come. Hence, we did two things. We eliminated the left pointer of 1, and then we brought out the correct order in the next, which we need to follow. And then we can call recursively for this 2 and can do the thing. So let us see the code for it. So we have simply called our function f. Now if root is null, we will simply return it. If roots left exist, now we need to do only if roots left exist, then we will make a temp variable as roots left, and a right, we will calculate a right node which is the rightmost in the temps subtree. So we will take out this node in the right node form. Now if roots right exist, then what we will do, we will simply do right nodes right is equals to roots. Right nodes right is equals to roots right. As simple as that. Roots right as temp and roots left as none. Now we will call again recursively. Now what is the find rightmost function? Simply we will go to the right until and unless we find null. Now whenever nodes right is null, we will return the null. This is as simple as that. So yeah guys, this was all from this question. Thank you so much guys for watching this video. Just in case you liked the video, you liked the question, make sure you hit the like button, press the subscribe button and share it with your friends. Thank you so much guys. We shall see you next.